What is a geological time scale? The geological time scale is a timeline that organizes Earth's history into distinct periods of time. These periods are marked by changes in the rock layers and the fossils they contain. The geological time scale is divided into eons, eras, periods, epochs, and ages. Let's take a closer look at each of these categories. Precambrian eon. The first eon, the Precambrian, covers the vast majority of Earth's history. It begins with the formation of the Earth and ends around 541 million years ago. The Precambrian era comprises all geologic time prior to 600 million years ago. Precambrian covers the vast bulk of the Earth's history, starting with the planet's creation about 4.5 billion years ago and ending with the emergence of complex, multicelled life forms almost 4 billion years later. The earliest known multicellular organisms are preserved in the Ediacara biota. Traces of life in Precambrian rocks are very rare. At the end of Precambrian eon, there was a period wherein the entire oceans and Earth's surface were covered with ice. This period is known as Snowball Earth. Snowball Earth is the period during which the continents and the seas were covered with the glacier around 700 to 650 million years. The ice prevented life from evolving. The sedimentary rocks such as Rapidan-type banded iron formation could not also form. This was because the ice prevented the interaction between the dissolved iron in the ocean portion and the oxygen in the atmosphere. However, the melt was later melted, probably because of the effect of global warming. This melting of the ice allows the interaction between the oxygen and the iron, forming BIF. Additionally, the vast explosion of life forms, scientists termed the Cambrian explosion, which marks the appearance of the Cambrian period, was also triggered. Precambrian comprises 3 eras from the base: Hadean, Archean, and Proterozoic. Hadean era. Hadean marks the time during which there was a series of asteroids constantly bombarding the Earth's surface, destroying all the life forms, rocks, and many others. This was a time described by fewer rocks and fossil records in the geological time scale because they were destroyed by lava and bombardment and because the temperature was too high to sustain life. The exception is there may be Hadean rocks in parts of Canada and Western Australia. In the Hadean eon, we obtained the formation of the Earth around 4.5 billion years ago, a heat source that could have evaporated the oceanic water. A magnetic field that started deflecting solar winds, making Earth more habitable, the formation of a moon, core accretion, and late bombardment stage wherein the asteroids strike the Earth's surface. This is why scientists suggest that comets may have transported water during the late bombardment stage. The Big Bang created all matter in the universe. This includes the Sun, planets, and our solar system. From a cloud of dust called nebula, gravity molded our solar system. The nebular hypothesis is the possible explanation for how the Sun, the Earth, and the rest of the solar system formed approximately 4.5 billion years ago out of the gravitational pull of a large cloud of gas and dust left behind from previous star formation and star life. Cycles. The pull of dust particles formed the protosun. As the nebula spins, more and more planets formed around the Sun. A nebula is an interstellar cloud of gas and dust. Most of a nebula's mass is made of hydrogen and helium, the simplest elements and the first to form after the Big Bang, along with some lithium. Additionally, nebulas contain heavier elements from beryllium up to iron, which are created through the nuclear fusion of lighter elements within star life cycles. Nuclear fusion reactions power the Sun and other stars. In a fusion reaction, 2 light nuclei emerge to form a single heavier nucleus. The process releases energy because the total mass of the resulting single nucleus is less than the mass of the 2 original nuclei. The leftover mass becomes energy. Elements heavier than iron such as gold, platinum, osmium, iridium, and many others require more energy to fuse and are therefore created in dying stars, or supernovae, which are the explosive end to some massive stars. The core accretion model describes the creation of our solar system. Solar winds swept in hydrogen and helium closer to the Sun because they were smaller in size. But the Sun could not pull in the heavier elements. Earth coalesced surrounding matter to form a sphere. This is why scientists suggest that comets may have transported water during the late bombardment stage. The Big Bang created all matter in the universe. This includes the Sun, planets, and our solar system. The Sun could not pull in the heavier elements. But the Sun could not pull in the heavier elements. They spiraled and gelled together into planets of their own. Earth coalesced surrounding matter to form a sphere. The heaviest material, like iron and zinc, sank to the core. Finally, lighter material remained on top to form a crust. From the core accretion model, Earth formed a solid iron core. Inside Earth, it was multifamily layered. Surrounding the inner core, Earth established a liquid outer core. Because the solid inner core heats the outer liquid layer, it produces convection currents. This Earth's magnetic field magnetizes the rocks to give their magnetic properties. This is why geophysicists use magnetic methods to find rocks such as magnetite, banded iron formation, etc. This Earth's magnetic field during Hadean times started deflecting solar winds, making Earth more habitable. The giant impact theory is most widely accepted today. This proposes that the moon formed during a collision between the Earth and another small planet called Theia, about the size of the planet Mars. The debris from this impact collected in an orbit around Earth to form the moon. Almost unrecognizable, heat flow was nearly 3 times as high as it is today from planetary accretion. The intense heat caused the oceanic water to be too hot, not able to accommodate the aquatic life. However, because of this intense heat, water would have evaporated into space. This is why scientists suggest that comets may have transported water during the late bombardment stage. Hadean is a time period described by extremely intense heat, eruptive volcanoes, and raining of meteorites and comets. The constantly eruptive volcanoes were spewing harmful gases and other materials into the atmosphere. These harmful gases and materials make it difficult to sustain life. The ocean lava blanketed the Earth's surface, melting every single rock formed. Therefore, no records of rocks of the Hadean age on the stratigraphy. This is because the geological processes were constantly destroying the rocks after their formation. The only piece of information of this time is the zircon crystals, which is known as Jack Hill's zircon. This is the oldest piece of Earth and is resistant to processes such as weathering and subduction, which is why it survived the harsh conditions during Hadean times. Archean era. The Archean ranges between 3,800 to 2,500 million years. The oldest rocks are preserved in the Archean era. These oldest rocks include basement Archean granites and greenstone belts. A greenstone belt is an ancient remnant of oceanic crust formed within the Proterozoic granite cratons. Stromatolites appear in the fossil record, and single-cell organisms evolved. Stromatolites are layered biochemical accretionary structures formed in shallow water by the trapping, binding, and cementation of sedimentary grains by biofilms or microbial mats of microorganisms, especially cyanobacteria. The abundance of these fossils by Archean times suggests that by this time single-celled life was already flourishing on Earth. Archean is also marked by the assemblage of supercontinents. The remnants of the oldest supercontinents of the Archean age are known as cratons. Cratons are pieces of continents that have been stable for over 1 billion years and are found located mainly in Africa, Australia, and Canada. These cratons form the nucleus of the continents. Though rivers, mountains, oceans, and many other features were there by the end of Archean, the oxygen was too abundant in the atmosphere. The air comprises large amounts of carbon dioxide and methane. This was a time during which there was an abundance of oxygen in the atmosphere known as the Great Oxygen Event. The oxygen was the byproduct of cyanobacteria. The oxygen in the deep sea was constantly bonding with the free iron, probably derived from the breaking down of ancient oceanic crust or hydrothermal vents. But there came a time wherein all of the free iron was used up. The buildup of oxygen was toxic to other organisms and cyanobacteria. As a result, the cyanobacteria died off and gave the precipitation of silica derived from the hydrothermal vents a chance in the deep sea. This appearance and disappearance of cyanobacteria gave rise to a type of banded iron formation referred to as algoma type. Proterozoic era. Proterozoic commenced at 2,500 million years to about 543 million years. Banded iron formations are deposited as oxygen atmosphere forms. The Rapitan-type BIF were dominant. These banded iron formations were formed during snowball Earth. This era is marked predominantly by the Ediacaran biota. The Ediacaran biota is a taxonomic period classification that consists of all life forms that were present on Earth during the Ediacaran period. These were composed of enigmatic tabular and frond-shaped, mostly sessile organisms. Ediacara biota or fauna represent a unique assemblage of soft-bodied organisms preserved worldwide as fossil impressions in the sandstone from the Ediacaran period, approximately 575 to 541 million years ago, after a series of ice ages just before the Cambrian. This period records the earliest known multicellular organisms, equivalent to Sonora, Ediacara hills, and White Sea. Examples: Dickinsonia, etc. The Phanerozoic Eon. Within the Phanerozoic Eon, we have the Paleozoic, Mesozoic, and Cenozoic eras. These eras are defined by major geological events, such as the rise of complex life forms and the extinction of dinosaurs. For example, the Permian extinction wiped out a vast number of species, and the KT extinction marked the end of dinosaurs. The Paleozoic era ranges between 542 to 252 million years, or from the Cambrian period to the Permian period. Mesozoic era ranges between 252 to 66 million years. Cenozoic era ranges from 66 million years to date. The Phanerozoic Eon commenced at 542 million years. Cambrian rocks and younger sedimentary rocks are called Phanerozoic, meaning visible life. At the beginning of Cambrian times, most modern phyla had appeared. Paleozoic era. The Paleozoic era commenced at approximately 542 until 252 Ma. This is the oldest era of the Phanerozoic Eon. Paleozoic is marked by the emergence of visible life forms, known as the Cambrian explosion. At the beginning of Cambrian times, most modern phyla began to appear in the geologic record. The Great Coal Swamps form as the Appalachian Mountains form within the Carboniferous period. But, within the Permian, this was the age of reptiles, and the supercontinent Pangaea formed as well at about 250 million years. At the close of this era, there was a major event that wiped out approximately 90% of all life forms, known as Permian mass extinction. Only other reptiles that were hidden below the surface were able to survive this, most probably because they were not affected by the harsh environments. These reptiles evolved into the dinosaurs. Mesozoic era. Mesozoic is the intermediate era of the Phanerozoic Eon. It is subdivided from the base into Triassic, Jurassic, and Cretaceous CJT. This ranges between 250 and 66 million years. The Mesozoic era is the time during which the dinosaurs ruled the Earth. Triassic period, the dinosaurs, i.e., warm-blooded, replaced reptiles, i.e., cold-blooded, as the dominant land animals. The Jurassic marks the period during which the dinosaurs became diversified. The break of supercontinent Pangaea, birds, and early mammals appeared. Cretaceous is the during time which the dinosaurs were at their peaks. Cretaceous or tertiary boundary extinction, also known as KP extinction, wiped out dinosaurs, Ammonites, etc. This event took place at about 66 million years ago. Several possible mechanisms have been suggested for this mass extinction, including a large asteroid impact and major flood volcanism. Scientists reviewed how the occurrence and global distribution of a global iridium-rich deposit and impact ejecta support the hypothesis that a single asteroid impact at Chicxulub, Mexico, triggered the extinction event. A giant meteorite hit the surface of the Earth, ejecting harmful materials from the ground known as ejecta. These harmful materials could have suffocated the dinosaurs. There are two types of dinosaurs. These are Ornithischia, also known as bird-hipped, and Saurischian, known as lizard-hipped. Ornithischian became extinct at the end of the Cretaceous. Some Saurischia survived the KP extinction and gave rise to modern birds. This era commenced 66 million years ago, and it is still ongoing. It is subdivided from the base into Paleogene, Neogene, Quaternary periods. It is the era which is marked by the mammals. Modern humans evolve and migrate around the world. Within this era, we have individual periods and epochs. Each period and epoch is distinguished by unique geological and biological characteristics. During the Pleistocene epoch, the Earth experienced multiple ice ages, shaping the landscapes we see today. The geological time scale captures the continuous changes our planet has undergone. It allows us to understand Earth's dynamic nature and how life has evolved over time. Scientists use the geological time scale to make connections between different regions, explore past climates, and uncover the mysteries of our planet's history. So, the next time you look at a fossil or examine rock formations, remember that you are peering into Earth's ancient secrets. Thanks for watching this video, and we hope you've enjoyed unraveling the wonders of the geological time scale. Don't forget to subscribe to our channel for more captivating content like this. Subscribe to our channel and stay tuned for fascinating insights into the world around us. Thanks for watching.